Good afternoon, all of you. I hope all of you had lunch. Okay. So now we'll start the afternoon session. That is by Professor Vinay Kumar. Vinay Kumar is from NIT Warangal. He completed his PhD also from same institute, and he is working there from last 6 to 7 years. He has already awarded more than 5 PhDs, more than 40 publications in IEEE transactions, and he completed 3 to 4 projects, SERV project and even ANRF projects. Okay, and he worked extensively in electric drive controls, motor drive control, and very down to earth personality. Last time also he visited. Okay, and whenever we tell him to, sir, please join us, he is already ready, and he all the way he came from Warangal to here by his own vehicle, by his own driving. so so he is passionate about driving.
Vinay Kumar, Assistant Professor, Department of Electrical Engineering. My area of research work is power electronics and drives. Particularly, I'm working on control of induction motor, control of PMSM machine, and control of synchronous reluctance motor. See, control the system. Right? See, based on this one, based on this concept, this is all systems. See, problem is even if you take DC machine, even if you take induction machine, even if you take PM, all electrical machines by nature, right? It is very complicated. The beauty of mathematics is by adopting mathematic technique and power electronic devices, combination of these two, we can able to control the variables effectively, right? Right? Any example? What are the methods by using various methods? How we can simplify? How we can eliminate the disturbance? Anyone? Simple example you can tell. This is the beauty of control method. What is our aim of today session? Our aim of session is control. What are the various control methods and challenges of electric drive? Before understanding the control methods, before deriving the challenges of the particular control method, first we should know what are the what is the nature of different electric drive systems. Right, before 1970s, most of the electric vehicles were operated with DC motors. Later, after 1970s, after proposing field orientation method, right, all DC motors were replaced with AC motors. Right now, anyone please give me any example? What is the beauty of control method? This is the beauty of control method. By nature, system is very complicated. By adopting the method, right, we can easily target the variable. That is the primary object of the control system. So in today's session, we'll try to focus on how to identify the control variables of electric drives. I have 2 hour session. If you are very strong in fundamentals, understanding the advanced method model predictive control, it is not a big deal. In today's session, I will try to more focus on model predictive control of electric drives, right? So before that, as electrical scholar, if you want to understand the system behavior, what parameter we need to focus? Now our system is electric drive. Now tell me, anyone, how we can understand the behavior of the system, how we can understand the nature of the output variable, how we can understand the system behavior? Hmm? Analysis of what? No. See, the beauty, the advantage of electrical scholar is we have only 3 elements, R, L, C, right? Particularly in drives application, we no need to consider the effect of the capacitor. You can neglect the effect of the capacitor. Anyway, you forget about R, right? Another important parameter is L. This is it. So as electrical scholar, if you concentrate about what is the nature of inductance offered by the system, based on the behavior of the inductance offered by the system, we can identify what is the nature of torque generated by the machine. That's it. If you take DC machine or synchronous or asynchronous machine or special purpose machine, right? If you focus on what is the nature of inductance, whether inductance is a variable or it is a function of, or it is a constant, or it is a function of rotor position. If you know the behavior of the inductance offered by the system based on the rotor position, you will get more clarity about the operating principle of the machine. Nothing is there. Now my question is, what is the mathematical model for inductance of the coil? How we can define? See, most of the things already you might have know mathematical model. Only thing is, whenever you want to understand the concept in detail, right? Your job is you have to analyze the concept beyond the limit in different directions so that you will get more clarity. If you want to get more clarity beyond the limit, only option is you have to depend on mathematics. That's it. So what is the mathematical model for inductance? Inductance of the coil L equal to Ls plus M. That's it. What is Ls? Self inductance. Right? What is M? Mutual inductance. If there is any other coil is there, on the rotor side, definitely mutual inductance will entering in the picture. Now my question is very simple. Take example, best example, induction motor and DC motor, right? Now in case of induction, otherwise for better understanding purpose, take salient pole synchronous machine and induction motor. Synchronous and asynchronous machine you can take. Now what is the difference between salient pole synchronous machine and induction motor? In case of induction motor, at any instant of the time, this component is independent of the rotor position. In case of induction motor, self-inductance offered by the coil, stator coil, will not change. Whether it is a stator coil or rotor coil, inductance, self-inductance will not change with respect to rotor position. Right? Mutual inductance is function of theta. Next, if you take synchronous machine, right, self-inductance as well as mutual inductance both are function of the theta. Now my question is very simple. What is the advantage? What is the advantage with respect to if inductance is function of the theta? What is the benefit you will get? Anyone? Inductance is function of theta is nothing but your inductance flux linkages changes, right? Energy stored in the air gap is regulating instant to instant. If there is any change in the energy in the air gap, what is happening? What is conclusion? Final conclusion. Energy is changing, decreasing or increasing, nothing but energy is converting. Whenever you want to convert the energy, necessary condition is winding inductance must vary with respect to theta. This is the basic principle for energy conversion or energy conversion concept. Whether it is a DC machine or AC machine, in all electrical machine, if you want to convert the energy, necessary condition is inductance must vary with respect to theta. If inductance is changes with respect to theta, definitely energy is converting, electrical energy is converted into mechanical energy. But if you take transformer, in case of transformer, throughout the operation, inductance is a constant. It will not change. So because of this reason, there is no energy conversion. Only energy is transferring from one coil to another coil. That's why it is called static device. But in case of dynamic machine, what is happening? Winding inductance is varying, right? So if there is any change in the inductance, definitely there is a field energy changes in the air gap. 97, whatever electrical energy you are supplying to the machine, 97% energy will convert it to field energy. Only 3%, less than 3% energy is dropped in the core. Whatever energy dropped in the core, that is unwanted, heating effect on it. Whatever energy is available in air gap is very useful component with respect to power developed in the rotor. Because of energy stored in the air gap, you will get back EMF. Back EMF is mainly because of energy stored in the air gap. See, already if you refer any standard textbooks, what is the mathematical model for power developed in the rotor? EB into I. Clear? EB into I. See, simple mathematical. How much back EMF you are developing in the machine is completely depends on the energy storage in the air gap, right? One more important question I want to ask here. What is the another advantage? If self-inductance is function of theta and mutual inductance is function of the theta, what is the advantage? In case of induction machine, self-inductance will not vary with respect to theta. Only mutual inductance is vary with respect to theta. But if you take salient pole synchronous machine, stator self-inductance as well as mutual inductance of the stator winding, both are regulating with respect to theta. So because of Ls is function of theta, M is function of theta, you will get reactance power as well as reaction power in the system. Reluctance torque as well as reaction torque both are induced in the system because of L self-inductance as well as mutual inductance. Both are vary with respect to theta. Then you will get two different nature of the components in the rotor. Now question is, what is the advantage? There are two powers are there in the armature circuit, what is the advantage? What is the difference between reaction torque and reluctance torque? Anyone? What is the basic difference between reaction torque and reluctance torque? If you take reluctance torque, it doesn't depend on the excitation. But if you take reaction torque, it is always function of the field current. Even if there is any fault in the field current side, even if your field circuit is getting fault, still your machine will operate, still your machine is will be drive by using reluctance torque. That is the advantage if there is any reluctance component is there in your system. Reluctance torque is so important, particularly in fault condition, right? Even field current is getting short circuit, field circuit is getting disconnected from the circuit because of some issues, right? Still your drive will operate continuously. Continuity of the operation is so important with respect to industrial application. Industry, with respect to industrial application, their requirement is reliability. Their top priority is reliability. Second priority is performance. What is the difference between reliability and performance? What is the difference between these two? Both are same or different? Different. Reliability is nothing but continuity of the operation. Performance means quality of the operation. Efficiency. Efficiency is secondary. The beauty of mathematics as well as power electronics is by adopting these two techniques, we can improve the efficiency. Improving the efficiency, it is not a big problem, but important thing is first you need to focus on reliability of the system. This is the top priority in industrial application, right? Now, even if you take self-inductance, again self-inductance having two components. One is called leakage, another one is called magnetizing inductance. Leakage inductance will not contribute to generate the twisting force, or leakage inductance will not useful to convert the energy. This is unwanted component. That's why practical condition, if you take any electrical machine to minimize the leakage inductance, they will try to minimize the air gap distance between the stator core as well as rotor core. This is what we are following, right? By decreasing the distance between the stator core and rotor core, leakage flux also will convert it to magnetizing flux. That is what we are following. That's why beyond 4 mm, we are not maintaining distance between the stator core and rotor core. Less than 4 mm, 4 mm is very, very less, right? If you maintain distance between stator core and rotor core less than 4 mm, leakage flux, unwanted flux also will become magnetizing flux. That is the advantage if you minimize the distance between the stator core and rotor core, right? What is magnetizing inductance? Anyone? How we can define magnetizing inductance? What is the function of magnetizing inductance? See, first 40 minutes I will try to ask fundamentals. Beyond that, I will not go advanced topics. What is magnetizing inductance? See, by using this slide, I will try to explain what is magnetizing inductance, at what condition your self-inductance is vary, at what condition your self-inductance is independent of the theta. I will try to explain. See, for understanding purpose, take, let us know this is stator coil A and A dash coil, right? Once you excite these two, A and A dash, what will happen? Immediately it will produce flux, right? So what is cross? Cross is nothing but current coming, coming or going inside. Going inside. Apply thumb rule, right, or thumb rule clockwise, right? So this is the path for the, this is the path clockwise. Now with respect to dot, current is coming outside, anti-clockwise direction. So once you excite the stator coil, now if you observe this diagram carefully, this is the axis of, with respect to rotor core, whatever flux is passing from stator to rotor through air gap, that flux is called magnetizing flux. Whatever flux is interacting with other core, that flux is called magnetizing flux. The function of magnetizing flux is always interacting with other core. So this is the position of north pole, this is the position of south pole due to stator current. If you observe this diagram carefully, right, conductor position is like this, pole axis is like this. What is the space displacement angle between these two? 90 degree. At any instant of the time, please try to understand, right? The space displacement angle between conductor axis and flux axis is always 90 degree, right? So whatever flux is passing from north pole to south pole through air gap, through rotor core, this flux is called magnetizing flux. Magnetizing lambda mu. See, issue is here, even rotor position is here or here, irrespective of the rotor position, this path reluctance will not change. If path reluctance is not changing, flux passing from north pole to south pole will not change. Nothing but throughout the operation, irrespective of the rotor position, magnetizing flux strength is constant. If magnetizing flux strength is constant, magnetizing inductance is also constant. So in this case, lambda m mu is is independent of the theta. It is not a function of theta, right? So here, if then assume that there is no coil on the rotor side. There is no coil on the rotor side. There is no M also. M is also 0. L is magnetizing self-inductance is independent of the theta. At the same time, L is not there in the single excited system. If your rotor is a cylindrical single excited machine, it won't generate any twisting force. Why? Because the nature of the coil inductance is independent of the theta. That's why designers, what they have done is intentionally they have designed other model. If it is a single excited cylindrical machine, it won't generate any torque. That's why assume that in case 2 also there is no winding on the rotor side. Once I excite these two, here north pole, south pole, flux is passing from north pole to south pole, right? In this case, what will happen, reluctance with respect to rotor pole position, reluctance is changes. If reluctance is changes, flux passing from north pole to south pole is changes. Here in this case, what is happening, magnetizing inductance is function of theta, right? You know about synchronous reluctance motor, switch reluctance motor, synchronous reluctance, all machines operating principle is like this. The basic principle of switch reluctance motor or synchronous reluctance motor is it will generate the reluctance torque mainly because of magnetizing inductance is function of theta. All are single excited machines. There is no winding on the rotor side. There are no permanent magnets on the rotor side. This, right? Clear? Anyone having doubt? So what are the final conclusion is here, if you want to generate the twisting force, necessary condition is your winding inductance must vary with respect to theta. If self inductance is function of the theta, you will get reluctance torque. If mutual inductance is function of the theta, you will get reaction torque, right? See, compared to reluctance torque, reaction torque strength is more. Why? Reaction torque strength is more compared to reluctance torque? Why PMSM machine becomes so popular than SRM, synchronous reluctance motor? Anyone? SRM is a single excited machine. PMSM is a double excited machine. What is the advantage? Double excited, interaction is more. If interaction is more, effectiveness is increases. Average value will increases, right? So compared to reluctance torque is mainly because of only single excited system. See, reaction torque is mainly because of mutual inductance. Mutual inductance, right? Next, I want to ask one fundamental question. Even if you take induction machine or synchronous machines, right? Stator construction is same. Stator construction of synchronous, asynchronous, permanent magnet, synchronous machines, synchronous reluctance motor, all machines stator construction is similar, right? Now, question is, what is the nature of mutual inductance? The polarity of the mutual inductance is always plus or minus. Whether, see, if there are any two coils are there, what will happen sometimes based on the current entering with respect to particular coil, resultant mutual inductance, it may become positive or negative. Now, what is the required polarity of the mutual inductance in all electrical machine? What polarity? See, they are while designing the machine, they will take care about the polarity of mutual inductance, even though it is a transformer or dynamic machines. Polarity of the mutual inductance is very, very important. Polarity of the mutual inductance is positive or negative? Required polarity. Anyone? At least one. Why? Why? If it is a positive, see, according to, there is a, see, everything, all systems are working based on the Newton's law. If there is a, if you want to do work, it required cause, right? If there is any cause is there, automatically effect is there, right? See, if it is a positive sign, what will happen in case of transformer basic principle is it is working based on mutual inductance, but mutual inductance polarity must be negative. The nature of the flux produced by the secondary coil must be opposed the primary flux. Otherwise, your core, it will enter in saturation. There is no energy transfer. If you want, you can check through simulations also. Through simulations, we can verify. The nature of mutual inductance must be negative. If it is a negative, then only based on the load requirement, your primary coil will draw extra current, extra energy from the source. That is what we have studied in the fundamental courses. What is the mathematical model for input current in transformer? I1 equal to I0 plus I2 dash. What is I2 dash? What is the function of I2 dash? The nature of the I2 dash is it is called load compensation current. If there is any burden on the transformer, then only I2 dash will entering in the primary side. If there is no burden on the secondary side, I2 dash is 0. Am I correct or not? I2 dash is entering mainly because of what? Load. Right? See, if it is a, the direction of magnetizing flux in transformer is, assume that at particular instant left to right, what is the direction of load flux? Opposite. Nothing but in this case mutual inductance is a negative, right? If it is a decreasing, this two, the resultant flux is decreasing or resultant flux is changing position, then only I2 dash will enter in the picture. Then only your back EMFs, induced EMF in the coil 1 as well as coil 2 will get disturbed. Intentionally we are creating disturbance. We have to create the disturbance, right? If you create the disturbance, if you see, by taking care about the winding design, if mutual inductance polarity is positive, advantage is we can able to transfer the energy. If it is a transformer, if it is a machine, dynamic machine, we can able to transfer the energy in stage 1. Later in stage 2, immediately whatever energy is transferred to air gap, that energy we can convert. That is what we are doing in all electrical machines. Mutual inductance polarity must be negative. If it is a negative, then only we can do job. Then only your I2 dash will enter in the picture. Otherwise, both are opposite, both are aiding to each other, simply your core will get saturation. Am I correct or not? There is no change in back EMF. If you want draw the power from the source, essential thing is your source voltage is very stiff. It is a constant, right? Only option in case of transformer is you have to change the back EMF. Back EMF is regulating. How back EMF is regulating? Based on the strength of the resultant flux available in the path. That the strength of the resultant flux always regulating based on your load burden. Am I correct or not? This is what. One more important basic principle I will tell. Even if you take DC machine or induction machine or any electrical machines, electric drives, see, compared to no load condition, under load condition, there is a lot of disturbance is there on flux density. In case of no load condition, flux is always distributed from north pole to south pole uniformly. But problem is, if flux is distributed uniformly, this is unwanted situation under load condition. That's why what we are doing is, intentionally we are supplying the current through the armature circuit. Whenever you supply the current through the armature circuit, then only stator flux and rotor flux both will interact. Resultant flux density will change. Resultant flux, if there is any change in the flux density, definitely there is a twisting force is there. Torque is mainly because of change in flux density. Torque is mainly because if flux is changes, your winding inductance is also changes. Right? So this are all the beyond this nothing is there in electric drive. There are three categories of electric drives are there. One is no magnetic salience, single magnetic salience, double magnetic salience. If you take single magnetic salience, right, what are the machines are single magnetic salient, nothing but IPMSM machines, synchronous machines. These machines are coming under this category. No magnetic salience, round rotary induction motors, surface mounted PMSM machines are coming under this category. Double magnetic salient, switch reluctance machine will come under this category, right? I think in last visit also I asked one question: what is the necessary condition to generate the torque? Till now we discuss about inductance. Layman, it is very difficult to understand what is inductance. Uh, they cannot understand. As an electrical scholar, how you can define necessary condition for generating the twisting force? Anyone? We have only two in electrical system. We have only two important potential element. One is torque, another one is voltage. Beyond that, nothing is there. Using these two variables, we can do job. If you want to do any job in electrical system, it required voltage. We are regulating the voltage so that we can satisfy the electrical circuits, right? If it is a mechanical system, if it is an electric vehicle or any robotic or aerospace application, if you want change the shaft position or if you want change the shaft speed, necessary condition is you have to regulate the torque. Torque is the main cost component to do the job in mechanical system, right? What is the necessary condition for these two potential useful component, these two? If you want generate the twisting force or if you want generate the electrical voltage, what is the necessary condition? Before that I want to ask one more important: what is frequency? That's it. What is F? Frequency. What is frequency? Don't tell number of cycles per second. See, as an electrical scholar, you have to analyze the what is the logic behind the number of cycles per second. You have to analyze what is frequency. How we can define frequency? See, frequency we can define based on the relative motion between the conductor and flux. That's it. Right? This is the basic philosophy behind to get the frequency in the voltage as well as current. Frequency is nothing but simple. See, conductor, relative motion between conductor and flux. Why brush frequency is 0 in case of DC machine? Brush frequency always 0. Reason is magnetizing flux is stationary, brush is also stationary. The relative motion between the brushes and magnetizing flux is 0. Relative motion is 0. Because of this reason, brushes always will collect 0 hertz signal. Even armature voltage or armature current is operating with rotor frequency, but brushes always will collect the 0 hertz voltage as or 0 hertz currents. Am I correct or not? Reason is frequency is nothing but relative motion between the magnetizing flux and conductor. That's it. Now similarly, what is voltage? See, as an electrical scholar, you have to remember one important term: relative motion. This is a very important term. If you want to produce the voltage, it required relative motion. If you want to produce the mechanical potential element torque, you need to maintain 0 relative motion between the magnetizing flux and armature flux. That's it. Nothing is there in electrical drive system. In electrical drive system, if you want to produce the twisting force, necessary condition is how much voltage you need to apply, right? Based on the requirement, how much back EMF is developed based on the energy conversion concept, If you analyze, then you will get more clarity about operating principle of all electrical drives. Right? See, if you want to produce the twisting force, necessary condition is related to motion between the magnetizing flux and armature flux must be 0. If you want to produce the voltage, you have to maintain forcefully relative motion is finite. Relative motion between the conductor and flux must be finite. Then only you will get electrical force. These two are useful component. Clear? Now why we need to discuss about frequency? Our topic is control. What we are going to control? We are controlling frequency. That's it. We are controlling the frequency of the supply voltage based on the customer need. That's why intentionally I want to know the how many participants know the state, know the behavior of the this parameter. Frequency is nothing but relative motion. Practical condition based on the customer need in electric vehicle, right? See, frequency component frequency of the applied voltage to the motor will decide how to decide the frequency, how to decide the RMS. After off session, I will try to explain in detail, right? So initially try to understand what is the frequency term, what is the torque, what is the voltage, right? This is about universal torque expression, which is common for all electrical machine. In last session also, I explained the concept behind this equation. Anyway, I don't have any option before explain control method. As a teacher, as a scholar, I need to explain the fundamentals again, right? If you take this equation, why I have taken torque profile? Why not other equations? Why not voltage differential equation? Why I have taken torque equation here? To explain the behavior of the different machines. The main hmm? Why I, okay. See, there are, suppose how we can evaluate the performance of the students, class students, based on CGPA. We don't have any option whether student is good or bad, whether it is coming regular or irregular, that is immaterial. If you want to evaluate the student, yeah, you need to go through the script. You have to evaluate the script, and based on this performance, you have to evaluate the, you have to assign the grade. That's it. We don't have any option. So see, with respect to students, CGPA is the expected output. CGPA is the output parameter. Similarly, if you take any electric motor, if your electric machine, if your machine is operating in motoring mode, expected output is torque. If I ask students also, even PhD scholars also, what is the output of the motor? If I ask, they will tell speed is the output, vibrations are the output, like that they will tell. Speed is the not output. Speed is mainly because of torque. Torque is the main cause component to do the job in the mechanical system. If you want rotate, or if you want change the position, or if you want to accelerate, main component is torque. So based on the torque profile, we can evaluate the performance of the various electrical machines. So as an electrical scholar, if you want to evaluate the performance of the torque profile for the various machine, you need to take universal torque expression. So whatever expression is there here, it is applicable for all electrical machine, DC machine, induction machine, round rotor synchronous machine, right? Surface mounted permanent magnet synchronous machine. For all electrical machine, it is a common. What is ZIS? ZIS is stator flux. ZR is the rotor flux, where delta is the space displacement angle between these two fluxes, right? So here, based on the torque profile, as an electrical scholar, you need to identify how many variables are involved in the system. If you take DC machine, in case of DC machine, this is the position of stator flux, this is the axis of the rotor flux. What is the angle between these two? 90 degree. If delta is 90 degree, then what is the advantage? ZS, ZR. No, you will not get maximum torque. Initially, this is the nature. This is the nature of the DC motor after adopting commutator. The beauty of commutator is it will maintain 90 degree between stator flux and rotor flux. If it is a 90-degree, there is a sine component is there, that one become maximum. Only sine component become maximum, but resultant torque it is not a maximum, right? If you want in electric vehicle or aerospace application or submarine application, robotic application, their requirement is your torque profile should be first order. Now here, how many variables are there? How many variables are there in torque profile? How many variables are there? Stator flux, rotor flux. Stator flux is function of IF, field current. Rotor flux is function of IA. IA and IF, these two are flowing to the coil. Nothing but these two are state variables. These two are variables. These two are not a constant. Based on number of variables involved in the torque expression, we can decide the order. Basically, DC motors are called second order systems. By nature, the all DC machines are in second order system. How we can decide? With many scholars, if I ask how to decide the order, they, first of all, see, whenever you want to decide the order of the system, first you have to understand what is the expected output of the system. Based on the output parameter, right, we can easily understand or we can easily derive the conclusion about the order of the system. Now here, now what is the advantage, what are the challenges? Our object of today's session is, first we need to understand the actual system behavior. Then after that, you need to identify what are the gaps in the existing system. After that, what are the control methods we need to adopt to improve the performance. That's it. Now tell me, what there is advantage is there. There is a limitation is also there. What is the advantage here? This is the universal expression. Advantage is sine component is eliminated because of commutator, because of frequency. Commutator is a frequency converter, right? It is a very beautiful commutator. It is a very beautiful concept they have invented, right? It is a frequency converter, AC to DC or DC to AC. Now, what is the advantage here? Because of commutator, del sine become maximum. What is the limitation here? What is the limitation? Your system is a non-linear. Why it is called non-linear? Why it is non-linear? How we can define system is a linear or non-linear? If there is only one variable is involved in the output variable, then it become linear. One variable is multiplied with another variable. Simple. Multiplication or division operators, mathematical operators are coming under non-linearity. Addition, subtraction, this one will come under the linearity, right? Now here, main advantage is it is a second order systems. Second order systems are mostly stable, but problem is instantaneous control is not possible. If you want to control the speed of the electric vehicle using DC machine, we cannot control instantaneously using conventional methods. That's why later they propose armature voltage control method. I think you might have studied in undergraduate course armature voltage control. What is armature control method? This is a method. It is an idea they have proposed to improve the performance of the actual system. Tell me, what is armature control method? In armature control method, throughout the operation, forcefully we are maintaining IF constant. Then we are regulating VA. That is what we are doing. If you maintain IF constant throughout the operation, what will happen? If IF is constant in the torque expression, then torque is directly proportional to Torque is directly proportional to Ia. Nothing but, see, this is the beauty of control method. The beauty of armature control method is second order system we can convert it to first order without, please try to understand. It is an idea, it is a mathematic technique, it is a method. By adopting this method without adding any physical components or without eliminating the existing components, we can change the behavior of the system. We can change the mental behavior of the system. That is what we are doing. All engineers, control engineers, what they are doing is through mathematics, they will propose the concept. Whatever idea is there in their mind, that idea they will convert it to mathematics. Once you're having mathematical support to your idea, implementation is easy through advanced controllers, DSP controllers, FPGA boards, right? There are a lot of advanced processes are there to execute your logic or to execute your instructions within short period. These are all the main challenges. How much time is taking to execute your logic is also very crucial in high performance electric drive systems, particularly in EV application, aerospace application, robotic application. Their requirement is execution time should be less, performance should be high. That is their requirement. Instantaneous control. If you want control the instantaneously, your torque profile should be linear. No option, whether it is a single phase system or DC system or three phase system or multi-phase system, right? Your torque profile should be linear condition. Linear nothing but one variable should be there in the output parameter. Now take induction motor. What is the order of the induction motor? Tell me how we can decide induction. In case of induction motor, no brushes, no commutator. Delta we cannot maintain 90 degree. So delta is also variable, right? Stator flux is also variable, rotor flux is also variable. Then what is the order? What is the order of the induction motor? It is a seventh order system. Why seventh order? Where size is the resultant stator flux after interacting A phase stator flux, B phase, C phase. After interacting three phase flux, right? Resultant flux is rotating in nature, right? Similarly, after interacting rotor A phase, B phase, C phase flux, you will get lambda r. So stator side there are three variables are there inherently. Rotor side also three variables are there. Delta is also variable. 3 plus 3 plus 1, 7 variables. There are 7 variables are there in the system, but still industry people they are adopting induction motor. 95% drives are induction motors on industry. Only few applications they are adopting special machines. They are adopting DC drives. Why induction motors become so popular even though torque profile is very poor? If number of number of variables involved in the torque expression is more, what is the issue? We cannot control instantaneously. We cannot regulate the variable instantaneously. If you want to regulate the parameter instantaneously, necessary condition is it should be linear. Anyone? Why induction motor became so popular? DC motors control point it is very good, but no one is using nowadays application. Induction motor performance is poor even though they are using for application. What is the reason? Cost very good, reliability. DC motors also self-starting. It doesn't require any prime mover during starting condition. See, top priority industry people, their top priority is reliability and maintenance. These two are very important parameters to decide the selection of the drive in particular application, right? See, if you take induction motor, 25 to 30 years, it doesn't require any maintenance. The lifetime of the induction motor is more than 40 years. If you want, you can use continuously without any maintenance, but DC motor lifetime is less than 15, less than 12 to 15 years on. At the same time, regular maintenance is also required. One more issue is it will occupy more space, particularly in aerospace application, electric vehicle application, submarine application. There is a limited space is available for drive system. What is drive? What is drive? Drive is a basically it is a mechanical energy producing device. If you take any drive, it will produce mechanical energy. That's it, right? Whether it is electric drive or IC engine or other hydraulic drives, all drives function is mechanical energy producing device, right? Why industry people? See, there is a limited space is there, then we cannot accommodate DC motors. If you take permanent magnet synchronous machine, advantages with less space, it will produce more power. Power density is very good for permanent magnet synchronous machines, right? That's why AC machines became so popular. Even if you take induction motor, size of the induction motor 3 HP machine size is like this. DC motor 3 HP machine size this much. If size is more, automatically weight it will increases, right? Tell me how we can say reliability is very good, at the same time maintenance is zero. Because of these two parameters, they will select the in AC machines. After selecting, what are the challenges? After selecting, main challenges are eliminating the nonlinear component. If you want to eliminate, how we can eliminate? We cannot eliminate simple like that. You need to, how we can eliminate? This is the remedy. You need to understand the system behavior through mathematics. This is the only technique we have. We don't have any other techniques. We don't have any, see, uh, only one option is, first you have to understand the system behavior through mathematics. If you know the system behavior through mathematics, then it is not a big deal to eliminate the non-linearity, right? Another important thing is you need to take care about the control complexity. If control complexity is more, number of PA controllers are more, it is very difficult to design. It is very difficult to execute the logic within short period. That is the issue. If control complexity is more, if control complexity is more, automatically computation become more. If computation time is more, definitely steady state performance will degrade. That is the problem, right? That's why, to minimize the complexity, right, later they have proposed transformation technique. Now question is, in last presentation also I asked about the transformation. What is the need of transformation? How many MTech students are there? Can you raise your hand? MTech and faculty? All are faculty. No MTech students. Ah, research scholars. Can you raise? Electrical research scholars. Only all are electrical. You know about transformations, three phase to two phase trans. Now tell me, what is the need of this transformation technique? Converting, okay. My question is need statement. No, that is what we are missing. What is the need of transformation? That's why I'm telling. Very good. We can understand easily. That is the main top right. Many scholars, if I ask what is the need of, they will try to tell. They will tell always minimizing the control complex. Control is a secondary. First, you need to understand the system behavior through mathematics. So while understanding the system behavior through mathematics, by taking natural system parameters, it is not so easy for scholars. That's why you need to apply transformation technique. By applying the transformation technique, we can understand the system behavior. You will get clarity about the system information in detail. See, best example I will tell. I see. Take induction motor. Take DC machine. Transformations are not required for DC machine, right? This is about separately excited DC machine. Here I will take empty slide better, so that I don't know whether I am going slow or fast. You have to tell. How many? Everyone is following? Fine, clear? Okay. See, problem with me is my lectures are going very slow. See, as per schedule, I will get 40 slots per semester. I will request students. I will take more than 52 or 53 slots per semester. Otherwise, I cannot complete the syllabus. Completing syllabus is not my objective. Understanding in detail different direction is what is the cause and effect, right? What is the basic now I will draw the circuit. You have to tell. Scholars are there. My main focus is on scholars. You have potential. You have to use in effective direction, proper direction. Then it become more effective. Now, tell me, what is the difference between these two? What is the problem with induction motor? What is the advantage of DC motor? By seeing the diagram itself, don't think too much about what is the required mathematics. Mathematics are not required here. By seeing the diagram itself, you can tell what is the advantage of DC motor, what are the challenges with respect to physical system, actual system. Observe this circuit carefully. What we are doing, whenever you want to control the torque in DC machine, forcefully you have to maintain magnetizing flux constant. Before maintaining magnetizing flux constant at rated value, first you should know how much current you need to maintain. If you see, that's why here ammeter is required. If you connect ammeter here, you will get information about IF, you will get information about IA. What is IA and what is IF? IF is called flux control device. IA is called torque producing device. That's it. In case of DC machine or induction machine or synchronous machine, permanent magnet synchronous, if you take any electric drive, there are only two nature of the currents will entering in the picture. One current function is it will magnetize the poles. Another current nature is it will generate the twisting force. Right? Now, in case of induction machine, what is the current passing through the induction machine? What is the mathematical model for I? I equal to, what is the mathematical? See, operating principle of induction motor and transformer both are same. What is I1? I1 equal to, very good, I0 plus I2 dash. What is I0? I mu IW. See, nowadays there is a lot of improvement is there in material science, right? By taking proper care about the materials, we can minimize the core losses. Anyway, core losses percentage is less than 2% compared to rated value. You can ignore this component. If you ignore this component, I1 is nothing but only I mu plus I2 dash, right? So if you connect ammeter here, you will get information about only I1. But what is the I mu, what is the I2 dash individual value, independent values, you will not get. That is the problem with induction motor by nature, right? So even if you take induction motor, finally there are two kinds of currents are entering. One is called flux control, another one is for I2 dash is nothing but load component, nothing but torque component. You got my point? So flux producing component, torque producing component, both are entering in the same path. Physically, in case of AC machines, current passing, flux control current and torque producing current, both are entering in the same path. That is the problem. Even if you connect ammeter or current sensors, right, you cannot get information about what is the percentage of I mu compared to rated value, what is the percentage of I2 dash compared to rated value, you will not get clarity. If you want to get clarity, you have to adopt transformation technique. It is a mathematic technique. It is a very beautiful concept to get clarity about the information about the I0 and I2 dash. So what is the function of, take this picture, observe this picture carefully. What is the object of this picture? It is a technique, mirror. By using this mirror, you will get information about opposite vehicles. You got my point? So first thing is, right, see here, there is a vehicle is there. Now reference person is sitting here. There is one more vehicle is coming opposite. This is a B. So with respect to this reference person, right, what he will do, he will observe the information. If there is any corner is a sharp curve is there, what he will do is he will observe the information. Based on the information, what he will do is he will control the vehicle speed. Control is a secondary. First thing is he will get the information through this technique. Similarly, right, using this transformation technique, different transformation technique, we can able to get the information. Right, now my question is how you will get information about IMU and I2 dash through transformations. Anyone? What is the philosophy? What is the philosophy behind to get the information, independent information about the IMU and I2 dash? You know about space vector concept? What is space vector concept? Any vector in space we can resolve into two components. One is in d axis, another one is q axis. See, in case of induction motor, the resultant current, what is the nature of the resultant current after interacting A phase current, B phase current, C phase current? The nature of the resultant current is always rotating in nature. If resultant current is rotating, resultant MMF is rotating, resultant flux is also rotating. Because of nature of the electrical force, only you will get magnetizing flux in rotating nature. Right? So the resultant flux is in rotating in space with supply frequency. Right? How many components are there inherently? One is magnetizing component, another one is torque producing component. So what they will do is they will apply complex vector technique, space vector technique. So by applying the space vector technique, this resultant current they will resolve into two components. One component they will transfer to d axis, another component they will transfer to q axis. Finally, even if you take resultant current or complex vector representation, finally inherently there are two components are there. After applying or before applying, there is no missing in information. Same information, right? Unknown information, hidden information, we can get through transformation, right? Where ID is nothing but flux control component, IQ is called torque control component. That's it. While controlling the machine, first what you have to do is you have to apply transformation. Once you apply the transformation, what will happen? Unknown magnetizing current information, unknown torque producing current information, you will get through transformation. Once you get the information, control, it is not a problem. That's why if you take any control method, model predictive control method or field orientation control method, all methods are working with respect to particular frame transformations, right? Some people they will adopt synchronous reference frame, some people they may adopt rotor reference frame, some people they may adopt rotor flux orientation, some people they may adopt stator flux orientation. Particularly if it is a PMSM machine, we don't have any option, you need to adopt rotor field orientation. Why we need to adopt orientation? This is a very important concept, orientation method. By adopting the orientation, control complexity further. First, orientation is very important with respect to control point of view. Transformation is the main object, primary object of the transformation is getting information, right? After getting the information, immediately you have to orient the variables. You have to rotate the variables with particular speed. If you rotate the variables with particular speed, advantage is control complexity will decreases. That is what we are following in all advanced control methods, right? So if you observe these three waveform, what is the common among these three waveform? There is a common point is there. What is the common point among these three variables? First one is natural system, three-phase system, right? Second one is Clark transformation. Next, second to third waveform is a Park transformation. Next 1 to 4, 1 to 4, sorry 1 to 3, it is a cross transformation, cross. 1 to 2 is a Clark. Next 2 to 3 is a Park transformation. What is Park? Two phase to two phase. Clark is three phase to two phase, right? See, practically no one is using Clark transformation. Cross transformation is so important for electrical scholar. What is the advantage of cross transformation? Natural variables directly will convert it to DC variables and two phase variables. If your variables are in DC with respect to control point of view, what is the advantage? You need to regulate only magnitude. Otherwise, if your control variables are in AC nature, it is very difficult to control magnitude as well as phase at particular instant. Clear? So if you want to control the torque instantaneously, you have to focus on only magnitude. Phase control, it is very difficult. That's why cross transformation is so important for electrical scholar, right? till now we discuss about what are the natures of see what is the fundamental concept, what is the need of controller. By using controller, we can minimize the order. If order is decreases, control becomes simple, target variable become very simple. That is what we learn up to now. At the same time, what is the need of transformations also we discuss. Then by using the fundamental concept and transformation technique, we can easily understand or we can easily implement model predictive control. See, I don't want to discuss conventional method. Before that I need to tell one important point. I'm having A4 paper, A4 empty, A4 paper, A4 sheet. Any even rough paper is also fine. Only A4 paper is. So using now I will try to explain. This is called universal block diagram, common for all electrical drives. Even if you take DC drive or AC drives, permanent magnet synchronous machine, switch reluctance motor or synchronous machine, this block diagram is common. That's why it is called universal block diagram. Right? If you observe these two, if you observe this diagram carefully, how many control paths are there? Observe diagram carefully. How many paths are there? Control path. How many inputs are there? At least observe carefully. There are only two inputs. This is one input. So your signal is control signal is flowing this path. This is one path. Another path is this one. Why only there are two paths are there? Any method, any closed loop operation if you take with respect to drive, there are only two signal. The main object of this path is torque control. The main object of this path is flux control. That's it. See, our target variables are always torque and flux. Why torque and flux? Why we need to target these two variables? These two are called target control variables with respect to electrical drive. If you take grid connected inverter, control variables are different. Real and reactive power they may target. In case of electric drive, our target variables are always torque and flux. Our focus as electrical scholar, your job is you need to control torque and flux instantaneously, so that we can meet customer required speed or position instantaneously. That is what we are doing in all electrical drive systems, right? Now if you take torque control path, right, how many see here, this is the position controller, speed controller, this is about torque controller, right? This is about flux controller. what is the name of, see, instead of that one, what I will do is I will eliminate position controller. In EV application, position controller is not so important. In robotic application, position controller is so important. In EV application, only speed controller is important. Take only this block diagram, right? Right? See here, how many loops are there? Observe. How many loops are there here? Two loops. One is, this is called current controller. This is called speed controller, right? Now, why current controller is placed near to power converter? Why speed controller is placed far from the power converter? What is the reason? If you want to understand this concept, right, this is called hierarchy. As a student, you should not interact director directly. If there is any problem is there, right, as a student, first you have to interact HOD. Still your problem is not rectified, then you have to interact deans. Still your problem is not rectified, then you can interact director. This is the hierarchy you need to follow. If you go directly, they will not listen. First question is, you have informed to HOD or not, they will ask, right? Here, particularly in electric drive application, based on the cause and effect relationship, you have to decide the position of the controller, right? Another important thing is, whatever controller is placed near to the power converter, that controller should work very fastly. Whatever controller is placed far from the converter, that controller bandwidth should be less. Even if it is working slow also, nothing will happen. But inner loop should be work fast. If inner loop is working fast, what is the advantage? Outer loop automatically will follow. Before, see, I will try to explain this concept through A4 paper so that you will get more clarity about the concept. Before that, through mathematics, I will try to explain. If you take armature circuit 1 by Ls plus R, what is the input to the armature circuit? Applied voltage. What is the output? Output is a current. Clear? This is called transfer function model of the armature circuit. Beyond that, nothing is there. Whenever you apply the voltage to the armature circuit, it will produce current. That's it. Right? So this is the input, this is the output. See, if you want to control the IA, only option is you need to regulate the voltage. Clear? Next, if you take, now I want, okay, before I see, whenever you want to develop mathematics, first important thing is you should know concept. You should know principle of the system. Without knowing the basic principle of the system, we cannot derive the equations, we cannot understand. What is the basic? See, how many circuits are involved in the electric motor? If you take electric motor, how many circuits are there inherently? Anyone? Any electric motor, whether it is AC motor or DC motor, how many circuits are involved in the system? That we should know. Armature circuit, field circuit, then mechanical circuit. There is a mechanical circuit is there, load is there, physical load is there, right? So there are three circuits are there inherently in all electrical machine. If you know the transfer function model for each circuit, so whatever, see here, this one LA RA, this is armature circuit transfer function model. If you take field circuit 1 by LF S plus RF, input is VF, output is IF. If you take mechanical system 1 by JS plus B, input is torque, output is a speed. That's it. Beyond that, nothing is there in electrical drive system, right? So using these three transfer function model, we can understand the system behavior. Once you know the system behavior, developing controller, it is not a problem, right? With respect to armature circuit, as electrical scholar, you need to understand what is the cause and effect. Whenever you want to control the current, what is the variable you need to regulate? With respect to armature circuit, this is called cause. This is the cause, this is the effect. With respect to field circuit, VF is the cause component, IF is the effect. With respect to mechanical circuit, torque is the main cause component, speed is the effect. right? Now cause and effect. Now take controller, you forget about current controller or speed controller. If you take any controller, what is the input to the controller, what is the output of the controller? If I ask research scholars, they are unable to tell what is the output. Input they can tell based on the reference. If speed is a reference, right? Feedback is a speed, right? So error is also speed. If I ask what is the output of the speed controller, they are unable to tell. How we can decide the output of the controller? Output of the controller we can decide based on the cause and effect relationship. This is the philosophy, this is the concept behind to decide the controller output nature. See, suppose if you take controller, any controller, the main object of controller is to eliminate the effect, error effect. That is what we are doing. We are minimizing the error. Error is minimizing is nothing but your actual signal is forcefully we are bringing in phase with reference. That is what we are doing in all control systems, right? Now error is the input. What is the output? Output is the your controller always will decide the cause component. If input is current, what is the output of the controller? How we can minimize the current error? By controlling the voltage. If there is any current error is there with respect to particular controller, your controller will decide how much voltage you need to maintain across the electrical circuit. It will decide. That is the function of controller, current controller. If you take speed controller, what is the, if it is speed controller, input is a speed error. Then what is the output? What is the function of speed controller? It will decide how much torque you need to maintain in actual system. If you maintain same amount of the torque in the actual system, your speed error will come to zero in the coming instance, right? Clear? Now my question is, why you need to keep speed controller away from the power converter? Why current controller is closely to power converter? The basic function of the power converter is it is a voltage regulating device. Am I correct? Through power converter, we can able to control average as well as RMS value based on the requirement. If it is a DC system, power converter always will control the average value. If it is AC, it will take care about the RMS value. Average and RMS, these two are very important parameters with respect to load. If you want to do any job, you need to maintain sufficient DC, sufficient average or RMS value. Your system will respond only for average or RMS value. Your system will not respond instantaneous voltages. Please start understanding. Even voltage is fluctuating instantaneously, right? Your drive is always rotating in uniform direction. Reason is how much RMS or average voltage you are applying across the motor terminal is so important. Your system will respond only for average value or RMS. It will not respond for instantaneous signals. Please start understand. This is the very important point common to all electrical systems. Not only electrical, any mechanical system also, it will not respond for instantaneous value. It will respond only for average or RMS value. Right? See, if now any current, so here speed controller, what it will decide? It will decide torque. What is torque? Torque is nothing but current only, IA. Am I correct or not? Torque is directly proportional to IA. So your speed controller will decide reference current. How much reference current, how much current you need to maintain in actual system through power converter will decided by the speed controller. If you compare the actual current with reference current, you will get current error. If there is any current error is there, through current controller, we can regulate the voltage. So in first instant, what is happening, right? Your voltage is regulating. Once voltage is changes, immediately current is regulating. Once current is regulating, then in next instant your speed is regulating. This is a cause and effect relationship. If you want change the speed, you need to control the torque or current. If you want control the current, main important thing is you need to regulate the voltage. That's why current controller, first you have to regulate. Current controller bandwidth should be very, very high compared to speed controller. What is bandwidth? Anyone? What is bandwidth? What is mean by bandwidth? My question is very simple. Bandwidth. See, that's why I'm telling. Whatever definitions are there in textbook or any, you should not tell. You all are electrical scholar. You have to think in other direction, so that you will get more clarity. Bandwidth is nothing but ability to track its reference. That's it. Bandwidth is more, system will track its reference very fast. Bandwidth is less, it will not track its reference. Very poor. That's it. Bandwidth is nothing but ability to track its reference. Now see, now for understanding purpose, take this A4 paper, right? There are two loops are there. This is inner loop, right? There is outer loop is there. My aim is I want to roll the paper effectively. I want to control the paper effectively. If you want, see, aim is customer requirement is rolling the paper. While rolling the paper, as electrical scholar, you have to apply control technique so that we can satisfy the customer. See, by taking inner loop as electrical scholar, now take inner loop and rotate it. What is happening? Observe carefully. See, initially outer loop diameter and inner loop diameter both are same. Now, what we are doing? We are controlling inner loop. I am not controlling outer loop. Observe carefully. Simply outer loop is, I am not controlling outer loop. See, only I have taken only inner loop. Now, what is happening? Outer loop is also following inner loop. Am I correct or not? This is what we are doing in electrical drives. If you focus more on the inner loop, automatically outer loop error also will coming down. Why? Because outer loop parameter, it is completely depends on the inner loop performance. If inner loop is working fine, why? Because see, current outer loop performance is mainly depends on the how much torque is developed on the system. How much torque is developed on the system is depends on how much current drawn by the machine. How much current drawn by the machine is completely depends on how much average or RMS value you are applying across the motor terminal is so important. Voltage is the main cause component to regulate the current. That's why through current controller we are regulating the voltage. By regulating the voltage we can minimize the current. By minimizing the current we can minimize the current error. See, current error is minimizing nothing but what is happening in next instant, torque, reference torque and actual torque is coming closely to each other, so that speed error will coming down. It is a very beautiful concept. Please try to understand. Whenever you want to decide the bandwidth of the, if there are any, this is called cascading connection. If there are any controllers are connecting in cascading fashion, deciding the bandwidth is, it is not a big deal. You have to focus on inner loop bandwidth, right? Inner loop bandwidth should be very, very high compared to outer loop. Now my question is very simple. How to decide the bandwidth of the loops? You got my question? Speed. Bandwidth is nothing but speed. What is, how much speed it will track its reference is nothing but bandwidth. How we can decide the bandwidth? Important thing is speed control bandwidth should be very, very less compared to current loop. Now, how we can decide bandwidth? Bandwidth is nothing but speed. Regulation of the variables. How much speed you are regulating the variables? How we can decide? Bandwidth of the controller will decide based on the switching frequency of the power converter. Right? This is thumb rule. You have to follow. Why? Because everything, cause and effect, we are minimizing the variables through power converter. Here main key point is power converter only. Main heart of the system, we are trying to regulate RMS and average values based on the customer need. Right? Power converter is a very important thing. Right? Through power converter only we can satisfy the customer. Through mathematics, through ideas, through armature control method, through model predictive control method, through field orientation method, we can satisfy the customers. Now, my point is, see, bandwidth of the loops we can decide based on the converter. But thing is, how we can decide the switching frequency of the converter. Bandwidth of the controller will depends on the switching frequency of the converter. Now my question is, how we can decide the switching frequency of the power converter? If I ask question to the students, they will tell switching frequency is more, losses are more, switching frequency is less, performance is very poor, harmonics are closely to fundamental if switching frequency is less. My question is very simple. How we can decide this switching frequency of the power converter? Whether it is a DC to DC or AC to DC or DC to AC. How much speed we have to operate the switch? What is the base for deciding switching frequency? No. What is our see, during starting session we discuss basic principle of the all electrical machine through inductance, right? So see, whenever you are deciding the frequency, switching frequency of the power converter, important thing is you should know what is the inductance offered by the motor, how much inductance effect is there in the system. You should know. If inductance effect is more, switching frequency required switching frequency more or less? Anyone? So there are two students are there, A and B students in the class. A student inductance is very good, energy storage capability is good. B student inductance effect is very poor, energy storage capability is very poor. There is initially there is no energy, but A student there is a sufficient energy is there before coming to the class. Then as a teacher, what we are doing? We are not spending much time on the A student. But as a teacher, you have to satisfy B also. Same topic you have to repeat. If energy storage capability is less, as a teacher, you have to repeat the same concept more than 4 or 5 times so that you will get more clarity. Nothing but as a faculty, you have to suffer. You have to operate more period. You got my point? If there is a sufficient inductance effect is there, energy storage capability is there, you no need to spend much time. That's why what is my request is, whatever topic you're focusing in your research work, see what is the main cost component, right? To understand the system, you need to derive the see, you have to identify in electrical, particularly electric drive system, we don't have any option. By taking inductance value, we can understand what is the nature of torque generated by the machine. We can understand how much switching frequency of the power converter we can understand. Once you know the winding inductance effect, right, value, we can easily decide the power converter switching frequency. Once you know power converter switching frequency, it is not a big deal to decide the switching frequency of the controllers, bandwidth of the controllers selection. It is not a problem. You got my point? Example, A and B students. A is very good, inductance effect is more, you no need to spend more time. Now tell me any example. In drives application, you need to spend more time or less time? In drives, if you take permanent magnet synchronous machine, inductance machine, if you take any electric drive, there is a sufficient inductance is there. But if you take LED lights or solar cells, solar DC to DC converter with respect to solar cells, right, inductance effect is very less. That's why DC to DC converters operating frequency is more than 100 kilohertz. Why LED driver circuits are operating with more than 100 kilohertz? Reason is there is system inductance is very less. But in our case, you no need to go beyond 5 kilohertz. In drives application, in electric vehicle application, operating operating switching frequency of the power converter is less than 5 kilohertz. Reason is there is a sufficient energy is there. You no need to worry. Filter is there. Filter is available, right? Even though you are applying see, through power converter, if you verify the output of the power converter, it is a non-sinusoidal voltage. It is a fluctuating voltage. Even though your voltage is fluctuating, but if you observe the current through the winding, it is coming very beautiful sinusoidal. Reason is, if it is a beautiful sinusoidal, you no need to worry, right? You can go for less switching frequency. Beautiful sinusoidal is mainly because of what? Winding inductance. Clear? That's why what is my request is how much time you are spending is so important to improve to get the quality of the work. Don't depends on the smart. In last session also I spoke same word. See, my choice is only spending time, right? How much time you are spending will decide quality of your work. Even you are smart also, no option, you have to take paper pen. As electrical scholar, derive the equation through cause and effect, then you will get more clarity. Once you get the equation, once you get the characteristic equation, it is not a big deal to extract the behavior. Once you know the behavior, we can easily derive the conclusion, right? Now come to another, see, so through these fundamentals we can understand one important topic, advanced topic. So these are all the various control methods, right? We are adopting in electric drive systems, particularly in electrical engineering. They are adopting so many methods. Particularly, see this method became so popular nowadays. What is the reason? I will try to explain compared to other methods. See, if any method is become so popular means there are advantages are there, at the same time challenges are there. What are the advantages? First, we'll try to discuss. After that, what are the drawbacks and how to overcome also we'll try to discuss at the end of today's session. Now take best example linear controller, PA controller. What is the problem with PA controller? Anyone? Not only PA controller, other than predictive controller, what is the issue? What is the problem with PA controller? It is a controller only. Input is error, output is a cause component, right? There is a problem is there with conventional controllers. What is the problem? Think. You have to think. Hmm? Anyone? Sir, what is time? Up to what? Okay. Within 15 minutes is fine. I will try to explain. I will try to uh, complete the topic effectively. What is the problem with conventional PA control? At least one student, one scholar. Think with respect to instant. Take instantaneous value. So what is my? I will take instantaneous. See kth instant, k plus 1 instant. This is the next instant, coming instant. Next k minus 1 instant. For understanding purpose, I have taken previous sample, current information and future. Now by taking these three combination, we can understand what is the significance of predictive control method, particularly in drives application. Take these three instances. Tell me what is the problem with conventional controllers. Here, understanding purpose, I have taken peak a computation is depends on overall instructions. What is the based on how many instructions, number of instructions you have taken to execute your logic. Based on that one, computation time will change. See, see, whenever you want to calculate how much voltage, suppose we'll take current controller. The main object of current controller is it will evaluate the required voltage. How much voltage you need to maintain across the motor terminal will decided by the current controller based on the current error. Right? This is current error. You got my point? This information, current information, from where you will get information? Whatever information is coming from the previous sample, that information, through that information, we can calculate the error. Based on the error, we can decide the voltage. So whatever voltage we are deciding, that voltage is responsible for eliminating the error at kth instant. But problem is we are applying this voltage across the motor terminal in the next instant. In current instant, we are calculating. We are only predicting the voltage. How much voltage we need to apply? You will get information through controller. But this voltage actually it will apply in the next sample. Whatever voltage will apply in the next sample, that voltage is only responsible for previous state error. Now there is a one sample delay is there between the cause and effect variables. There is a one sample. Because of one sample delay, if you observe the performance, see, if you observe the performance, right, you can notice the ripple in the generated torque. There is a lot of ripple is there with conventional controller. Second one is predictive torque controller. Right? One, see, we should not ignore even one sample delay is also there. In predictive controller, what we are doing is, see here, see, I will try to explain what we are doing through predictive. Before that, it required fundamental. See, whenever you want to implement predictive controller, see what information is required. Tell me. Now, I want to implement predictive controller. What information you should know? First, if you observe, the full form of this predictive controller is MPC. If you observe this title, if you analyze the title in detail, you will get more clarity about what is the objective, what is the outcome of the concept. What is their M? Model. What is their P is nothing but predictive. Then there are three objectives are there in model predictive control. First, you should know model. Once you know the model of the particular system, it is not a problem to predict the performance, right, in coming instant. What is the nature of the current? What is the nature of the error in the coming instant? We can predict through model. Am I correct or not? If you know the model, we can predict the information we can predict the error information at k plus 1 instant. Once you know the information about error, what is the nature of the error in the future sample, control it is not a problem. Very simple. That's why 80% time, whatever time slot you have, 80% time you have to spend on the model only. Once you're having model, right, next prediction of the variable, it is not a problem. Then after predicting, control become very easy. Right? That is what we are doing. I will tell this one. So see, based on the mathematical model at kth instant, what we are doing, we will predict the error information one sample ahead. Right? Based on this error information, through model predictive controller, what is the required voltage? Also, we can predict. So this voltage vector will apply in the k plus 1 instant. That's it. Whatever voltage vector is applied at k plus 1 instant, that voltage vector is responsible for same instant error. There is no delay between the error and there is no delay between the cause and effect. If there is no delay, automatically your performance will improve. That's it. You got my point? Even sample time is less, right? You should not ignore the delay time. Why? Because over the period, right, if you observe the performance, definitely it will degrade because of conventional controllers. By adopting this model predictive control method, right, we can improve the performance, right, through delay compensation. This concept, through this concept, we can effectively apply the voltage. We can eliminate the error effectively without any delay. Clear? These are all the major applications of the model predictive control method. Initially, this concept they applied for chemical industries. Later, the same concept they are adopting in electric vehicle application, aerospace applications also. Right? If you want to implement this method, important thing is you should know information about the actual system model. Model information is required. At the same time, power alternating module information is also required. Once you know the power electronic module information, Now my question is very simple. What information is required with respect to power converter? Anyone? What information is required? Now there is a power converter is there. Assume that example voltage source inverter is there. What information is required with respect to voltage source inverter? Switching states. Through switching states only we can able to control resultant voltage. How you are controlling the resultant voltage is so important to regulate the torque instantaneously. That is what we are doing in all methods: direct torque control method, field orientation method, model predictive control method, right? Next, that is about finite number of switching states. How many switching states are, how many switches are there? It is easy to calculate how many switching states are possible. What is the resultant voltage vector offered by the particular inverter? You will get clarity. Then after that, constraints. How we can apply constraint based on your requirement. If you want target two variables, you can take two variables. If you want target more number of variables, you can extract and you can keep in cost function. That is what we are doing in model predictive control. Right. Next, one more main problem with conventional controller is it is applicable only for single input and single output. But model predictive control method is applicable for multi input and multi control variables. Right. So this is about important. This is the heart of the model predictive control method. What is there in model predictive control method? Observe this equation. Till now we discuss conventional PA control. Through conventional PA controller we discuss hierarchy of the electric drive, right? Inner loop, outer loop we discuss, right? Here in this case there is no inner and there is no outer loop. There is only one loop. There is only one path. Simple. What is there in cost function? There is a control variables. Our target is control the torque, control the flux. That's it. So whatever variable you want to control, right, you should know what is, how much deviation is there between control variable and reference variable. If you know the error, right, how we can minimize the error? This is cost function is nothing but error only. How we can minimize the error? How we can minimize the error? No. What iteration? We do. Correct. Your point is correct. More iteration in more, with more iteration, what we'll do? What is the control variable? See, target variable is torque and flux. What is the control variable? How we can control these variables? Through voltage, through switching states, right? That's why what they will do is, see, assume that if you take two level voltage source inverter, there are six switching states are there: V1, V2, V3, V4, V5, V6. So what they will do is they will iterate the cost function with available 8 switching states. There are two null vectors are there, 6 active voltage vectors are there, right? At what instant, at what voltage vector your cost function giving minimum value, right, you need to calculate that voltage become optimal voltage vector for next sample. That's it, simple, right? So this is these all are modeling equations, modeling of the induction motor, right? So finally they will calculate cost function. Cost function is nothing but error on, right? Best example, see, I will take this example so that this is our sample here, right? At this instant what they will do is, at, see, they will iterate the cost function. This is current control, right? So if you apply V1 voltage vector, the expected value of the current is here. If you apply V2 or V6, expected value of the current here. V0 and V7 expected value of predicted, right? How current will behave in the next sample period, that is what we are doing. So these are all the future response of the current if you apply different switching states. So compared to different switching states, if you select V2 and V6, the expected position of the current is coming closely to our reference. This is our reference, right? Nothing but your expected actual value is coming closely to reference, nothing but error become minimum. So finally, where V2 or V6, these two are called optimal voltage vectors in the next sample period, right? So see, this model filter control method, based on your requirement, you can control the current through voltage source inverter, right? Active front end rectifier also, if you want, you can, if you want control the real and real. See, you can use this model filter controller for different electric system applications, or real power control, reactive power control, voltage balance application, voltage control in UPS application. If you want control the switching frequency, you can control, you can adopt model filter control, right? Common mode voltage in open and winding machines, if you want, you can. Even multi-phase machines also, if you want, under fault conditions, if you want balance the MMF also through model filter controller, through proper transformation technique, it is possible, right? Capacitor balance in multi-level inverters also, you can use model filter control. Only thing is, see, whenever you want to control something, what is the cause and effect, that you should know. If you know the cause and effect relationship, developing control logic, it is not a problem, right? So main challenges, what are the challenges with model filter control method? Tell me, what is the main model predictive control? This concept is applicable only for digital systems. This logic we cannot implement in analog, right? It requires digital controller. Next, one more important thing is this, through this model predictive controller, we are deciding the optimal voltage vector. Completely, model is nothing but there are inherently, there are actual system parameters are involved in this equations. But practically, your system parameters always will change. Winding inductance will change, winding resistance also, it will change based on the temperature effect, right? Based on the load current, inductance will change based on the temperature, resistance also will change. So model if your prediction is very crucial. If you are not predicting accurate value, your voltage vector will not control the actual system effectively based on the customer need. That is the main challenging with model predictive control. So that's why there is a lot of research is going on model predictive controller to develop the, to predict the voltage vector without model. You got my point? What I'm, you have to predict the voltage vector, but you have to eliminate the model. In this direction, there are a lot of papers also there, right? If you have interest, you can go through it, you can check. Now with model, there is a issue is there, it is very sensitive to the parameters. That is the problem, right? These are all the challenges and control methods with respect to electrical drive. If you have any doubt, you can ask, otherwise I will stop here. Anyone having doubt? Yeah, FPGA, DSP, even micro, even normal through Arduino also we can implement. It is not a problem. But it should be a digital controller. So analog it is not. Why? Why? What is the difference between analog and digital? Anyone? Discrete time. Okay. Anyone? My question is very simple. What is the difference between analog and digital controller? Think. Think, and you have to analyze. You have to analyze. You can think. It is applicable to digital controllers. It cannot, using analog controllers, we cannot implement model protocol. Why? Because sample time it is variable in analog, but in digital controller you can define sample time based on the length of the program. Once you know the execution time, we can decide the sample. Computation time and execution time, these two has to synchronize. this is very important. This is what we are learning normal MATLAB. This is what we are following. Sometimes your computation time it may exceed the sample time. In some cases, the program will complete within the sample time. No issue. But in real time, these two are coming under offline simulation. Whatever MATLAB is there in your system, that is offline. Once your MATLAB is integrated to physical controller, then it is coming under real time simulation. Right? In real time simulation, whatever sample you are taking within the sample time, you have to complete the task. After completion of the task, you will get the result. Whatever results are there in a particular instant, that results are acting as the input data to the next sample. That's it. This is simple concept behind the all controllers. Right? So execution time, sample time should be greater than the execution time. Execution time is depends on your skills. If you write the program with less instructions, automatically sample time will coming down. If you write the same concept with lengthy program, your sample time automatically will improve. Okay, sir. Thank you. Any questions? You have to ask questions. You know questions. There is a technical electrical side. Questions nothing but back EMF. If you ask questions, means we can control the current, right? Back EMF should be there. Back EMF is there, then only we can understand there is a energy conversion is happened. There is no back EMF, there is no energy conversion. So what is the final conclusion? What we discussed now? Everything observe today's session, everything we discussed through inductance. Beyond that, nothing. Right? First, initially we discussed the nature of the system through inductance. Later, how to decide the switching frequency of the power converter through actual system inductance. Then, after that, control methods, challenges, control method, right? So understanding the system behavior through particular energy storage element is very important. How many energy storage elements are there in your system?
Any questions? I think there are no questions. Thank you, Professor Vinay Kumar sir, for the exhaustive session on modeling, especially mathematical modeling. Yes, sir. Actually, this is a very tedious job, designing controllers and programming it and in operating in real time, that is hardware in loop. We have visited his labs last semester when I went to Warangal. Okay, so they have done a lot of hardware in loop work, and in real time they are controlling the system. Okay, so there are many faculty members who are working in this domain. That is the advantage of NIT Warangal. Okay, so thank you, sir. Thank you for coming all over the distance from Warangal to here and delivering this lecture. So now I will request Professor Amarendra sir to felicitate Vinay Kumar sir with a token of love and appreciation with a small memento. Thank you, sir. Now I request Professor Amarendra sir to brief everyone about tomorrow's plan.
Very good evening to all. We are one step to close this FDP. Tomorrow is the last day, you know. Before I could have to be mention something, because tomorrow is a very important day to us to successfully close this FDP. in this regard, I have to mention some points in this point. So as you and as we already communicated few things, and I want to again mention the same thing. Tomorrow we have morning one session, and after that 12 o'clock to 1 o'clock you have to be exercise your article summary and you have to submit, and it is a mandatory event. As in the my inauguration also I have mentioned, your articles are already circulated in WhatsApp group. You had on that format is also circulated. Everyone has to submit your article summaries given by the team, and you have to submit with your names. It is a group or individual, anything can be done, right? So if you are making a group, 4 5 members, we can make a group and you can submit your summary, but it should be in the format of what AICTE has given. And also individually, if you are interested, you can do individually also, but representing giving the submission is very much important, otherwise it cannot be evaluated in your certification. That is the one point number one. And the second, after the lunch session at 2 o'clock you will have a small assessment test which will have 20 objective questions with a timing of 20 minutes, right? So everyone, you can, we have a lab here, and also because it is in mobile it is not possible to take the test. We have computer lab there, everyone, and that is very important, otherwise your certificate won't be generated if you are not attempting your test. That is the second important point. And third one is very more important is we have reflection journal. There you have to submit individually, not a group. You have to mention what learning outcomes you have taken from this FDP and what you are going to implement. I think already format has shared to you also that one. That has to be submitted individually, not a group. It should be individually. Each and every participant has to submit. We'll provide one mail ID for all. It is a soft copy only. There is no hard copy submission required. We need a soft copy of that. So that is mandatory. That is also mandatory to submit by tomorrow only, because after that it is not possible to be collected, right? So these all are what I am saying tomorrow. So reflection journal, and next another important part is your feedback. So AICTE has created a feedback in the ATAL portal only. If you submit the feedback, then only your certificate will be generated. Without, if you are not submit, somebody I have written test, but feedback if you are not submitted, your certificate won't be generated. So you have to complete your feedback 100%, then only your certificate will be generated. And also AICTE has given one more feedback outside your login. You just go into ATAL login, and outside, what is the reflection of this FDP? Whether it is encourageable or not, AICTE are expecting some survey feedback. So you have to fill that one and give some positive remarks of what FDP you have attended, where it is attended, whether offline is effective, online is effective. Some questions they ask. It is a reflection of FDP, not individual FDP, personal. This not for this FDP. Overall, ATAL FDP, they want to take some survey. That is also, it is not mandatory, but it is a positively we are expecting to fill, because AICTE are much more programs they want to design with your feedback. So that is also be, you can complete it. And also few of them who are, we need expecting some project summary report, which you already taken MATLAB sessions. So there, if you have small project report, if you are submitted, that could be submitted in our end. So these all are mandatory things before our validatory function, and tomorrow only we have to close this one. And one more thing I want to mention here, each candidate will get your traveling allowance. So tomorrow after your all submissions, we are going to provide a traveling form to you. That form will you fill it and return back to our team, so that your traveling allowance will be credited to your accounts. It will be credited to your accounts based on who are having more than 20 kilometers from the station. Everyone will get eligible to get your TA. So one side, one side coming and one side going. You will get that as per AICTE ATAL norms. You will get it. That form will be circulated tomorrow, and you fill it and give it to our team. They will take it all necessary action for your traveling. I hope, and it is very mandatory for tomorrow's sessions, and all the participants has to attend physically. We need a group photo at the end also again. We need a head count, because we are showing attendance, but head count is much more important to us while we are giving a group photo. So how much number we are showing, that much head count in the photo shoot we require. So we are requesting everyone has to be present tomorrow. So in the group also we'll keep the same request to attend tomorrow's activities which are very important. After 5 days, outcome will be on tomorrow. So everyone, I hope very effectively and very interestingly you will participate in tomorrow's activities.